Dear students, in our operating system tutorial, today we will discuss introduction to process. Okay. As you know, when a program is in execution, it is called process. So let's start process. Before starting, I want to introduce myself. Myself, Niladji Shekhar Pal. I am working as an assistant professor at Greater Kolkata College of Engineering and Management. That's Computer Science and Engineering. So what is process? An instance of a computer program in execution. Okay, so a process is an instance of a computer program in execution. Sometimes it is also called as a job of stack. Process on modern systems can have several threads of execution or several different pieces of the program running in parallel. Each process has its own private resources, data and associated statistics. Okay, so what is process? A process is an instance of a computer program in execution. Okay, so as you know, all the programs resides in secondary memory. Okay, when we want to execute any program, it comes to the primary memory. Okay, so then it is called a process. Sometimes also called a job of task. Okay, why it is called a job of task? When you want to execute any job, okay, then that program is called process. That is why it is called a job of task. Process on a modern system can have several threads of execution. Okay, as we have read in our earlier tutorial that a process consists of many threads. Okay, or several pieces of the program running in parallel. So a process consists of many threads. Okay, and all these threads are executed parallelly. So the process becomes much faster. Each process has its own private resources, data, and associated statistics. Okay. Next, process management tasks, okay, are associated with this type of work. Processes are doing this type of work. Number one is suspending and restarting the process. Second one is offering mechanism for process communication. Third one is offering mechanism for process synchronization. Next, process scheduling and threads on the CPU. Fourth, create and delete system and user processes. Okay, so there are two types of processes. One is input-output bound process and next one is CPU bound process. So what is input-output bound process? Basically, it is input-output bound process is a type of process, okay, in which the process execution time is calculated with the help of the amount of time a process spends to complete the input-output operation. So what is input-output bound process? It is a type of process, okay, where the process execution time is calculated with the help of the amount of time a process spends to complete the input-output operations, okay. So the time required to complete input-output operations of a process is called input-output bound process. Next comes what is CPU bound process. CPU bound process is another type of process in which the process execution time is calculated with the help of CPU speed. Okay, if we use a faster processor, then the CPU bound process may execute faster. Okay, so in case of CPU bound process, okay, it totally depends on the CPU speed. Okay, so if we use faster CPU then processor, then the CPU bound process may execute faster. Okay, so as we have seen, there are two types of processors. One is input output bound process and another one is CPU bound process. So what is input output bound process? Input output, in case of input bound output bound process, the total executed time is depends upon the total input output operation. Okay, so the total time required to complete all the input output operations. Okay, and in case of CPU bound process, what's happened? In case of CPU bound process, it depends totally on the CPU speed. If the process CPU speed is faster, then the CPU bound process may execute faster. Okay, next come, what are the components of process? There are basically four components of a process. Number one is text, second one is data, third one is stack, and next is heap. So what is text? So you can see this is a pictorial representation. At the low level there are text, and there and above text there is data, and then heap, and then the stack. So now discuss what is why it is, what is this text, what is data, heap, and this stack. Okay. So what is text? Text basically contains of the value of the program counter and the processor's registers content that is represented by the current activity. Okay. So it consists of the value of the program counter and the processor's registers content that is represented by the current activity. Next one, data contains both static as well as global variables. So this data part basically it contains static as well as global variables. Next, stack. Stack basically contains temporary data like local variables, return variables, and other method functions. Okay. So stack contains this type of temporary data. And heap is a dynamic memory which is basically a dynamic memory, okay, which is allocated during the runtime of a process. Okay. So there are four types of components in a process. Number one is text. Basically it consists of the value of the program counter and the processor registers content that is represented by the current activity. Okay. And what is data? Data contains both static as well as global variables. And what is stack? Stack basically contains temporary data like local variables, return, address, and other method functions. And what is heap? Heap is a dynamic memory which is allocated during the runtime of a process. Okay. So next we will discuss different attributes of process. Okay. So the attributes of a process are called the context of the process. These attributes design the process control block. As you know, process control block is a very important part of a process. Process control block basically hold all the details of a process. Okay. So what the attributes used to store the process control block are process ID. So these are the things which are process control blocks hold. Number one is process ID. Second one is program counter. Next, process state. Next, priority. General purpose registers. List of open files. List of open devices. Okay. So these are how they can reside in the process. Okay. So at first process ID, next program counter, next process state, priority, general purpose registers, list open files, list of open devices. Okay. So we'll discuss now one by one this process ID, program counter, and all these things. So what is process ID? Process ID is a unique ID that is assigned to the process at the time when the process was created. So when the process was created, a process ID was given. Okay, this is the unique. Okay, all no second process have the same ID. Okay. Next one is program counter. The program counter holds the address of the last instruction of the process. Basically, it is a counter. Okay, it holds the address of the last instruction of the process to track which instructions have executed last. Okay. Next, process state. Okay, because there are basically this state may be one of the following states, that is running, ready, waiting, terminating, etc. In our later next tutorial, when we discuss the different life cycle, the life cycle or the process of different life cycle of process, then we will can see that a process may be in one of these states: running, ready, waiting, or terminate. Okay. So next, what is priority? Some priority is assigned to every process in the memory. The process that has the highest priority between the processes gets the CPU first. Okay. So some priority was given to some important processes. The process which has the highest priority will execute it first. Next, general purpose register. These registers are used to store data. Okay. Basically, general purpose registers are used to store data. Okay, at the time of process execution. Next, list of open files. A list of open files contains some files that requires to be present in the main memory when the process is executed. Okay, so to execute a process we need different types of process. Okay, so for that different types of process need to be opened. Okay, to execute a process. Okay, so list of open files. Okay, it contains that those files. Okay, list of open devices. Okay, so this list of open devices contains all the devices which are open, okay, but which are required to execute a process but during the process execution. So list of open devices contains the list of devices that are used when the process is in execution. Okay, so this is about the basic of process. In our next tutorial, we will discuss how the process will execute. Okay, different states of a process. I am requesting you to subscribe my channel. You will get a bell icon on your right hand side of the screen. You can click to get all the notification of my tutorial, or you can visit www.facebook.com/digitalclassroom to get all the latest updates of my tutorial. If you have any query, any doubt, you can mail me at nilajikil86@gmail.com, or you can call me at this number. Okay. So, students, thank you. See you in the next tutorial. So students, welcome once again in my operating system tutorial. In our previous lecture, we have discussed process. Okay, so we have today in this lecture we will discuss process control block or PCB. So this is again once again a very important topic for your semester examination. Myself Niladri Shekhar Pal. I am working as an assistant professor at Greater Kolkata College of Engineering and Management at Computer Science and Engineering Department. So what is process control block? It is basically, but the full form of PCB is process control block. It can also be called as task control block. Why it is called task control block? Because all the tasks are completed, okay, using this PCB. Okay, so all the process that is executed can be tracked using this PCB, or we can rather say that all the details of a process is stored by the PCB. It is basically a data structure that contains all the information associated with a process. Okay, so execution of a process may require to store different information about that process. Okay, like in which state the process is, or which instruction will execute next, or what are the files required for executing that. Okay, so there are lots of informations are there which required to be stored in PCB to execute a process. It is basically maintained by the operating system for every process. Okay, so as you know that in operating system there are two types of memory. One is secondary memory and another one is primary memory. Okay, so at first program stayed at secondary memory, and when the program is in executable states, it comes from secondary memory to primary memory. Then it is called a process. Okay, so there may be lots of processes can run simultaneously in the operating system. Okay, so operating system needs to store all the details of those processes, as the process operating system needs to store those information, because it will otherwise the all the processes may be in stagnant way. Stagnant way means that there is a situation of deadlock. There may be a situation of deadlock that may happen because all the process want to execute at the same time. Okay, next you can see that there is three processes P1, P2 and P3. Okay, so there are three processes. Okay, so as we have told that PCB stores the details of the individual process. Okay, so there is a PCB. Okay, for P1 there is another PCB for P2 and there will be another PCB. Okay, for P3. So if there are n number of processes, there are n number of PCBs. Okay, that are that are in the operating system that will hold to hold the details of the process. As you can see that this is PCB1 for P1 which holds the information of P1. Again there is another PCB2, this holds all the information of process 2. Once again there is another process that is PCB3 and this PCB3 stores all the details of P3. Now come, what are the things that contain PCB? That means what informations are stored by the PCB. First one is pointer and second one is process state. Pointer basically, as you know that there are lots of processes. We will discuss about different states of a process in our next tutorial. Okay, so what is basically, there are lots of states that when the process is in secondary memory, then it is a, and when there is process is not created, we can say that the process in new state. Okay, so after creation it will go to the ready state. So there are many other states like suspended, terminated. Okay, so there are lots of states are there. Okay, so process transfer from one state to another. Okay, so this pointer basically holds the information of current state, so that when a process transfers from one state to another state, it will again come back to the previous state. So it holds the information of current state. Next is process state. Process state is nothing but it holds only the current state of the process. Suppose it may store new, it may it may store ready, it may store terminated, it may store hold or suspended. Okay, so these are basically states. Okay, and all these state of the process are stored by this. Okay, next is process number. As you know, an operating system may run multiple processes simultaneously. Okay, suppose there are n number of processes, and to identify individual processes, all the processes are assigned a unique number or a unique ID by which a process can be identified uniquely. No two processes have the same ID number. So this is the process number. So what is process number? Process number basically holds the ID or unique number of a process. No two processes have the same number. So this is a unique. As we know in DBMS we have primary key. What is the required for primary key? Primary key, by primary key we can identify uniquely an entity. Similarly here, using this process number, unique process number, we can identify a process efficiently. Next comes program counter. A process or a program may consist of multiple steps or multiple instructions. As we know, as you can see that in C program, or you can see that in the summation of two numbers, there is two or three instructions. Suppose at first we have to take all the integer values, then we will assign those values to the variable, then we will summation of two variable. After that we will print the sum. Okay, so a program may contain, or a process can contain multiple instructions. Program counter basically stores the next instruction to be executed. So what is program counter? A program or process may contain multiple instructions to be executed. Okay, so program counter basically holds the
next instruction of the process that will be executed after current process. Next is registers. Okay, registers are nothing but the small storage section. Okay, which is required to store like accumulator, this type of things. Okay, so it is basically used to store small data. Okay, which is required by the operating system. Next is memory limits. As we know that there are basically two types of memory. One is primary memory and one other is secondary memory. Basically, all the programs reside in the secondary memory. When the time at the time of execution, this secondary memories, second processes comes from secondary memory to primary memory. Okay, and if there is a uh, conjunction, or we can say that if there is a lots of processes in the main memory, as we know that the main memory storage is very less as it is costly, so those processes which are in the main memory are came to the secondary memory. So memory limits is very vital thing. Okay, it basically stores the amount of memory that is assigned to the process. Next one is list of open files. List of open files, you can see that these are the dotted, these are the basically files. Basically, to execute a process, we need different types of processes. Okay, so these processes are required to execute those, or these files are required to execute a particular process. Okay, without these files, a process cannot be executed efficiently. So to execute that process, that all those files will be in the open mode. Okay, so these are the open list of open files. Okay, so this is the list of those files this is required to execute a process. So now you can see that pointer. It is basically a stack pointer which is required to be saved when the process is switched from one state to another to retain the current position of the process. As I have told earlier, that this is the pointer is basically is required to save the current position of a process, because when a process switched from one state to another state, it required to retain the current position of the process. For that, this pointer is necessary. Next one is process state. As I have told earlier, it basically stores the respective state of the process. Okay, so in a particular time, it will store a particular state. Next is process number. Every process is assigned with a unique ID. As I have told, this is the unique ID, okay, known as process ID or PID, which stores the process identifier by which we can identify a process uniquely. Next is program counter. It is basically stores the counter which contains the address of the next instruction to be that is required to be executed. Okay. Next one is register. Basically, as I have told, these are the CPU registers, okay, which includes accumulator based registers and general purpose registers. Okay. Next one is memory limits. This fields basically contains the information about the memory management system used by the operating system. This may include the page table, segment tables, etc. Okay. In our memory introduction to memory or memory chapter, we will discuss these page tables and segment tables. Okay. Next is open files list. This is basically the information that includes the list of open files or operands for a process. Okay. So this will stores all the details of the files that are required to execute a process. Okay. So as you can see that this is a this is the PCB for P1 process. This is the PCB for P2 process. If there are n number of process, n number of PCBs will be there, and this tag basically this tag basically holds all the processes, and all these PCBs basically stores the details of individual processes. These PCBs basically hold the details of individual processes. Okay. individual processes, PCBs. Okay, but this is stored all the details of all the processes. Okay, so as you can see that suppose this is the PID, that is PID1 means process 1. Okay, so this will contain, there is a PCB. Okay, so this will stores the address of PCB1. Okay, from this address we will go to the PCB1. Okay, again there is 2. Okay, for that there will be another address, so from that address we will go to the PCB2. Okay, so this is the pictorial representation of PCB. So students, this is all about PCB or process control block or task control block, what you will say. Okay, so in our next tutorial or next video we will discuss different states of a process. That is very important. Okay, if you have liked my channel, if you have liked my videos, you can like my YouTube channel or subscribe my YouTube channel to get all the video details. Or you can visit www.facebook.com/digitalclassroom and like my Facebook page. Okay, to get all the details. If you have any query, any doubt, you can mail me at niladjipl86@gmail.com. Okay, students, thank you for now. See you in the next tutorial.